In the previous video, we introduced unsuspended promises and looked at the basic motivation for using them. And so in this video, we're going to get into our editor and look at some simple examples. So if you're using Node.js or a node-based build process, you can go ahead and install the npm package unsuspended promise. So you can just do npm install unsuspended-promise, and you can replace npm with whatever package manager you're using. So in my case, I'm using pnpm. Now, if you're not using an npm-like package manager, feel free to just copy the JavaScript files directly into your project. So you can get those from the link to the GitHub repo in the description. So now let's go ahead and create an app.js file. And let's just quickly head over to package.json. I just want to change the type to module so that Node.js treats this code as the ESM format. Lovely, so let's head back to app.js and let's go ahead and import unsuspended promise. Now you can use either snake case or camel case. I have both versions exported, whichever you prefer. And let's just do a basic test to make sure our code is working. So we'll just send a HTTP request to Google, await that, and then get the text and await that too. And we'll just grab the first 15 characters in uppercase. And if we run that, then everything should be working. So as a simple example, let's just wrap this fetch function with unsuspended promise. And so that should convert that into an unsuspended factory. And so we should be able to remove all the extra await keywords and parentheses. And so if we run this, we should get the exact same result. Amazing. So that's just showing that unsuspended promise is successfully chaining our property access and function invocation, producing a larger promise as a result and effectively moving all the asynchronous initialization logic to the location of the final await keyword. So if you want a recap of how all that works, you can just check out my previous video, which I've linked in the description below. So now we'll move on to 3 sample use cases for unsuspended promises. So the first one is going to repeat what we actually had in the previous video. So we're going to create an asynchronous createDB connection function, and we'll populate this with some dummy hypothetical initialization logic. So we'll initialize our SQL library, instantiate a connection, and obtain some IP address for that connection. And then we'll enable debugging on that connection and then wrap this connection in some shape or form. And you can imagine a bunch of extra initialization logic, and the key here is that this function is asynchronous. So I'm just going to create a helper timeout function, which resolves after a certain amount of milliseconds. And then I'll just create a dummy implementation for all this initialization logic. So we're just going to use a bunch of timeouts everywhere to demonstrate the asynchronous nature of this initialization. So let's create a DB connection instance and then run an imaginary query on this connection. And without using unsuspended promises, we have to await both lines here. So let's just run our code and make sure that's all working. So as you can see, it outputs that it's performing the query and then outputs when it's finished. Now let's go ahead and alter createDB connection and wrap this initialization function in unsuspended promise. So this should now convert our factory into a synchronous appearing one, so we can just remove this redundant await keyword. And if we run the code again, we should get the exact same output. This is brilliant as it showcases how we can abstract away the asynchronous initialization workflow from the user of the factory. What's also amazing about this is that we can move the creation of the DB connection above this fetch example we had at the beginning of the video. And because we've removed the need to use the await keyword here, we're not unnecessarily delaying this fetch request until the DB connection is ready. And so we can see how unsuspended promises promotes parallelization here. Quick detour, this video is sponsored by me. I've just launched a new technical research service called Condensus Lab. Whether you need initial research and ideation, technical feasibility validation, prototyping for your technical project, or just want to chat, you can select the appropriate package for you. We're happy to engage with any technical aspirations, and to help me go bankrupt quicker, the first 20 people to use code Vibe Coding will get 75% off their first consultation. Check it out at lab.condensus.com, link in the description. Now let's get back to the video. Next, let's look at an object-oriented style format for performing object initialization. And we'll look at the various strategies that the developer might use to improve this process, and then we'll see how unsuspended promises is a great solution too. So let's create an example service class with a synchronous constructor. And we're going to have to do some asynchronous initialization here, and so it's quite a bummer as we can't use the constructor to help us out. A common approach in this case is to create a separate async init method. and this will perform all the necessary steps. Now, one thing you certainly would not want to do is just call this init method in the constructor, as there's then the danger that the user of this class might start using all the methods before the initialization has completed. And so it seems like a bit of a tricky situation because we can't prevent the constructor from completing before the class is fully initialized. And so a simple but perhaps annoying solution to this is to put the burden of initialization on the user of this class. And so they would have to be trusted to await the initialization logic. This can be seen as quite a downside, as the programmer has to ensure that no other code touches this service object until this initialization is finished. So if this service is a member of another class, then there's always that risk that other methods in this class might touch this service. Or if this service is being created in another function, we might suddenly have to make that function asynchronous. So there's quite a bit the developer has to worry about here, and don't even get me started with how painful this is when circular initialization is needed. Our next approach is to create an async factory, similar to our first example. Now, this strategy is great from a safety point of view, as there's no risk anymore of forgetting to initialize the service or to access the service object before the initialization has completed. But it does suddenly put the burden on the user of this factory to await this initialization and essentially forces any functions that are using this to be asynchronous. And this propagation effect is rather unpleasant. Okay, so now a third option is to alter the start of each of the service's methods to await initialization there. So we can simply create some sort of a ready promise in our constructor and await this process at the beginning of every method. This way, the construction process can remain entirely synchronous. We'll immediately have access to our instance, even if there is still some asynchronous work under the hood. And since the methods of interfacing with this object are themselves async, then we can happily await this logic there instead. So the key takeaway with this snippet is that the construction of an object does not have to be async if we make all methods of interfacing with the final object asynchronous. Regardless of our approach, having to architect around this seems like an unnecessary nightmare for the developer, especially given that writing good concurrent code is already quite demanding. We will instead see how unsuspended promises may be a much more attractive solution here. Notice the similarities of this last approach with how unsuspended promises function. Here we are manually moving the awaiting of initialization logic to the start of any of its methods, allowing us to maintain our synchronous behavior. With unsuspended promises, however, there is an equivalent effect, but in an automatic and simple fashion due to the way operation chaining works. So if we take our asynchronous factory version and just wrap this in unsuspended promise, essentially the awaiting of initialization logic is now automatically moved to the invocation of any of its methods. So we can now call createExampleService without any await keyword, and so you can see how unsuspended promises precisely achieve our desired outcome. Let's look at one final example in this video to really show how unsuspended promises are beneficial. This example is going to involve nested initialization, where the initialization of a monkey object is going to depend on the initialization of both a banana and a tree. So let's create some dummy banana and tree factories, and we're just going to use some timeouts like before. And now let's create a monkey factory. Now traditionally we'd have to make this factory asynchronous, so that we can create banana and tree by awaiting the factory, and then we can return whatever methods that this monkey should possess. So now we can instantiate our monkey and then call the climb method, and if we go ahead and run our code, you can see everything working as expected. Now this time we're not actually going to make the monkey factory unsuspended. Instead, let's assume that our dependencies have already been unsuspended. So let's wrap both the banana and the tree factories in unsuspended promise. Now we can immediately chop off the await keywords from create banana and create tree. And so now we can just get rid of async on this factory entirely. And so we do not have to even consider making this monkey factory unsuspended, as it just remains synchronous to begin with. And so really this power of unsuspended promises can be seen when we have nested initialization, and when we can unsuspend the underlying initialization, then any outer initialization can just remain completely synchronous. Notice also that banana and tree are entirely independent from one another, and so they're automatically going to initialize in parallel. What's also interesting about this is if we go ahead and run our code, you'll notice that the climb method finishes a little bit faster than we might expect. And without the developer having to even be aware, it turns out that this climb method does not actually depend on banana and tree. And so you can imagine some methods in your class might not actually depend on every aspect of initialization. And so if any particular methods do not depend on this initialization, then these methods can start working immediately. The code implicitly looks at the granular dependency graph, and not a more coarse one that the programmer accidentally achieves due to littering await all over their codebase. If the programmer has to worry about using await everywhere, they risk accidentally slowing down the program. But with unsuspended promises, it automatically ensures the correct features are initialized, and code can start working immediately as soon as its implicit dependencies are resolved. A keen eye might sense an opposing force to function color, and if you're not sure what that is, I'll leave a link to a great article about that in the description below. But in summary, function color is about this idea that if we need asynchronous code somewhere, then this asynchronous requirement is propagated to all users of that function. And so any outer functions need to become asynchronous, and then any outer functions from there also need to be marked asynchronous. And this is something that anyone who has written a lot of JavaScript code would observe on a daily basis. So the unsuspension of the dependent factories, which is create banana and create tree, actually promotes non-asynchronous code. As a result, a significant portion of our code can enjoy synchronous initialization, something previously unheard of, due to the unsuspension of its dependencies. And of course, this is contingent on its own exposed interface being async. So we're not necessarily removing the async nature, but we're just moving it somewhere else, and this ensures as much code as possible can remain synchronous. In particular, however, I wonder can we further unsuspend its own exposed interface? A killer blow to function color entirely. Well, maybe we're getting a little bit ahead of ourselves. So what we're going to do is get back to that in a future video on this topic. So in the description below is a link to my original article on this topic, and also the entire playlist of all my videos. So as I release new videos on unsuspended promises, I will add them to that playlist. So do stay subscribed so you don't miss out. But anyway, that's going to mark the end of this video. I'd love to hear your thoughts in the comments below, and if you've enjoyed, don't forget to leave a like. I will try have episode 3 for my operating series out in the next few months. So thank you very much for watching, and I'll catch you next time.